Which two molecules are hydrolyzable lipids? The answer are waxes and triacylglycerols. So remember, a wax is a heavy ester, and triacylglycerols have 3 ester linkages. So remember, general generic formula for an ester is that. So if you have an ester moiety or group that can be hydrolyzed or broken apart using water, sorry, it's out of order. Which two jobs are performed by lipids? The answers are A and B. Energy storage is done by triacylglycerols or triglycerides. And membrane formation, that's done by phospholipids. Next question. Rank the following molecules according to melting point. Enter the name of the compounds with the lowest and highest melting points. So the lowest is linolenic acid, because it has the most carbon-carbon double bonds. And the highest melting point is stearic acid, which is a saturated fat, which has no carbon-carbon double bonds. Okay, next, consider the figure describing transport across a cell membrane. Label each blank as either facilitated transport, diffusion, or active transport. Blank 1 is diffusion. Small molecules, they're just going through the membrane. There's no facilitator at all, just passive diffusion through the membrane. 2, so this symbolism here of 3 to 1, high concentration, lower concentration through a transporter. That's facilitated diffusion. And last is active transport. Again, 1 to 5, 1, 2, 3, 4, 5. This going from low concentration to high concentration. Okay. Again, it requires energy. That's active transport. Next question. High density lipoproteins transport cholesterol from the blank to the blank and is considered let's fill in the blank cholesterol. Right? So we look at each of those. HDL transfers cholesterol from the tissue to the liver. Okay, and that is considered healthy cholesterol because that is a clearance mechanism. It's a way of clearing and keeping your blood vessels clear from lipid or cholesterol buildup. And the way you can recall is, remember, LDL, low density lipoprotein. L, you can think of it as being lousy lipoprotein. Next question. Identify the prostaglandin molecule. through. Answer is D. How you know? It's that 5-membered ring. That's indicative of a prostaglandin. This molecule, well, it's just a hydroxylated fatty acid. This is a phospholipid, phosphate group in it. And this is a cholesterol specifically, but it's got that steroid or sterol ring, indicative of steroids or cholesterol. So D is a prostaglandin. Next question, moving to amino acids and proteins. Which amino acid is a Zwitter ion? If we look at all of them, the answer is B, because +1, -1, no charge. That sums to be 0. +1, -1, +1, sum to +1, +1, -1. This molecule is neutral, but it's not a Zwitter ion because there are no charges. So the answer is B. The sum of the charges is 0. Okay. Next question. Identify the peptide bond in the structure. The answer is B, 2. That's the linker. That specific, that links 2 amino acids together. The amino group being linked to the carboxy group, making the amide, linking everything together. Next question. Consider the molecule below. How many amino acids are in the molecule? Go through and look for peptide bonds. 1, 2, 3, 4. Okay, 4 peptide bonds. Another thing we can look at too is that's an alpha carbon. Hydrogen's its side chain. That would be glycine. 2, alanine. Valine. Serine. And then aspartic acid, aspartate. So we've got 1, 2, 3, 4, 5 side chains and 4 amide bonds, 4 amide bonds linking the side chains. So this is a pentapeptide for 5. Just to put that out, it's like you have 5 amino acids linked by 4 peptide bonds. Next question. Match each intermolecular force in the list below with one of the lettered features in the figure, the protein structure. Each answer should be a single letter, A or D. So, so if we look at A, the figure's a little bit, we've got an amino group and a carboxy group, positive charge and a negative charge. So that A, because you've got charges, would be a salt bridge. B, those are all non-polar bonds. So B is hydrophobic interactions. D, see that a little bigger. Those are sulfur atoms. That's a disulfide bridge. And then C, an OH bond, an NH bond, and then you've got OH, OH, C is hydrogen bonding. Try to make that a little clearer. It's highlighted in green. It's the hydrogen bond. Remember, you have to have a nitrogen, hydrogen, oxygen, hydrogen, or a fluorine hydrogen bond in order to have hydrogen bonding occur. Next question. Which statement describes the secondary structure of proteins? So read those. Secondary structure describes the amino acid sequence of proteins. Secondary structure describes the localized shape of protein, including alpha helices and beta sheets. That's it. A describes primary structure. C, secondary structure describes overall folded structure of a protein. It's tertiary. And D, secondary structure describes structures composed of two or more protein chains, including hemoglobin and antibodies. That's quaternary structure. Next, meringue is the result of whipping egg whites into a soft foam, which forms and is commonly used in desserts. Which protein denaturing condition is the most important for the creation of meringue? A, pH changes. B, addition of heavy metals. C, use of detergent, use of mechanical stress. And E, use of high heat. Well, whipping or whisking egg whites, that's mechanical stress, okay, mechanical agitation. Okay, those other methods can be used to denature a protein, but in the case of making egg whites, you just have to whip them.